Did a passing star change the Earth's climate in such a way that life emerged? A new study proves that a star passed by our solar system 56 million years ago and changed the orbits of the planets including Earth through its powerful gravitational forces. The new scientific findings prove that there is a link between stellar transits and the mysterious events within the solar system. A passing star may have triggered our own existence, and now we urgently need to ask ourselves when the next major stellar transit will be, possibly bringing another dramatic change. The influences that stars exert on each other are a field of astronomy that has hardly been researched to date. Researchers are only slowly beginning to understand the dramatic effects that star transits may have had on our solar system and life. During a stellar transit, another star approaches our Sun and enormous forces are at work. Stars are not in fixed positions within the galaxy, they move through space together with their planets. Due to very slow movements, other star systems can occasionally pass very close to ours. Such stellar rendezvous are rare, but researchers are now proving that they have happened and that they have had a massive impact on the world and the solar system as we know it today. Today our closest cosmic neighbor is the Alpha Centauri system at a distance of 4 light-years. We feel nothing of the influences or interactions between the Sun and the 3 stars of the Alpha and Proxima Centauri systems, but these stars are not always our closest galactic neighbors. At least since the discovery of stellar dynamics, we know that stars also undertake interesting migrations within the solar system. Over the course of billions of years, our Sun and its planets have passed by many other stars, and other stars have passed close to our Sun. A star that comes close to our Sun also exerts enormous forces on all the planets. It is possible that some planets have changed their positions within the solar system as a result of such encounters. Now researchers from the Planetary Science Institute in Tucson, Arizona claim to have found evidence that such a stellar transit in the Paleocene era significantly changed the Earth's climate, and that we humans may also owe our own existence to such a rare stellar event, a stellar transit 56 million years ago. It sounds like something out of a science fiction movie, but it is reality. Around 56 million years ago, a star passing close by could have had a dramatic impact on our solar system. This event may have changed the orbits of the planets and the Earth's climate so drastically that life on Earth developed decisively. This fascinating hypothesis has been proposed by computer simulations to explain some of the peculiarities of our solar system. The Paleocene and Eocene is an epoch that began about 10 million years after the extinction of the dinosaurs. During this time, the early ancestors of modern mammals such as primitive primates, smaller eulids and simple carnivores lived. The researchers were particularly interested in the so-called Paleocene-Eocene thermal maximum, a period of rapid global warming during which the Earth's temperature rose by up to 8 degrees Celsius. This rise in temperature could have triggered a growth in species. More food in a different climate gave rise to more complex species and new habitats. With the help of simulations, researchers now have discovered that the orbits of the outer planets such as Jupiter, Saturn, Uranus, and Neptune could explain the climate change. A star passing close to our system may have upset the planets at the edge of the system through extreme gravitational interactions, and there were also significant effects on the inner planets, including our Earth. The scientists go on to explain in their paper that while there are other explanations for previously unsolved mysteries in the evolution of the solar system, the computer's calculations suggested that the probability of such a stellar transit is about 1 in 10,000 over the last 100 million years. Compared to other probabilities and cycles in the universe, this is of very high value. Did humans evolve through a stellar mutation? But what phenomena and anomalies do scientists actually want to explain with these simulations? On one hand, there are unclear questions regarding the development of our planets. Some planets show evidence that they were in a completely different position at the beginning of the solar system. In the case of Mercury, for example, it is often assumed that it was once located behind the Earth or Mars and was then pushed inwards by Jupiter's gravity. Neptune is also suspected to have once had a different position. In the case of the ice giant, which today forms the end of the outer large planets, the scientists assumed that it was initially much further inwards in the solar system and then moved outwards. However, there is another possible scenario for Neptune. This planet is so strange within the structure of our solar system that scientists speculate that Neptune migrated from another solar system. Either it was a vagabond planet that was then attracted to and incorporated into our Sun, or Neptune changed systems as part of a major stellar encounter and slipped from its star system into ours. The simulations showed that the gravitational perturbations of passing stars have significantly influenced the orbits of the planets over millions of years, and they show the observed changes in eccentricity and inclination that our Earth's orbit has undergone over billions of years could be influenced by passing stars. The last time such an influence on the Earth's orbit occurred was during the Paleocene-Eocene epoch. If such an event 56 million years ago caused a rise in temperature and a change in the Earth's climate, the star transit had an impact on the Earth's flora and fauna, and of course on the further development of life. It's crazy, but some researchers are even of the opinion that life could be passed on through such stellar rendezvous in space. The researchers use various scenarios to explain exactly what this would look like. Asteroids and comets populated with bacteria could have flown into our solar system from a passing alien star system. The first signs of life appeared on Earth around 4 billion years ago. It's quite possible that there were also one or more large star transits at that time in which life was exchanged between two systems. Another scenario is that such transits can trigger spontaneous mutations in nature. This would explain, for example, why in our world mammals such as apes have suddenly become complex life forms like us humans. The orbital history of our Earth is directly linked to the development and change of life and living conditions on the planet. Only tiny changes in the tilt or rotation of the Earth can have drastic climatic changes on the entire system. The simulations used by scientists from the USA in their study showed in detail how a passing star can significantly influence the Earth's climate. For example, the amount of solar energy reaching the Earth could have changed, and this in turn affected the climate and possibly the release of methane from the ocean floor. A superlative stellar encounter is like a trigger for a chain reaction of events and changes. We are only just beginning to understand our Earth's climate, the complexity of ecosystems, and our own evolution. If the new ideas are correct, we must now think beyond the dimensions that are only happening on our Earth and in our immediate surroundings. Our planet was not only formed by internal processes, the Sun, or encounters with other planets in the solar system. Other stars and star systems have also helped to shape the world. Now you're probably wondering how likely it is that such an event will happen again. Once again, the researchers have used their computers and calculated the probability of an approaching star with new simulations. However, these studies showed that another major stellar transit is only conceivable in the very, very distant future. What happened to Jupiter, Uranus, Saturn, and Neptune? I bet you didn't know that Jupiter and Saturn were previously considered to be the great creatures within the solar system. Next to our Sun, these two are the largest objects within the solar system, and it is certainly true that they exert considerable influence on smaller planets. Jupiter has probably pushed little Mercury closer and closer to the Sun, and one day it could hurl Mercury completely into the Sun, or Mercury could fly out of the solar system under Jupiter's pressure. Jupiter also binds hundreds of thousands of asteroids and chunks of rocks in the asteroid belt, and thus protects us to a certain extent from the flying chunks. Despite its size, Saturn doesn't have quite as much influence because although it's the second largest in the ring, it is also the fluffiest planet in the solar system. If we were to throw the gas giant into a pool, it would be so light that it would float on the surface like a rubber ducky. Nevertheless, the large Jupiter alone cannot be responsible for certain anomalies in the solar system, which is why the researchers came up with the idea of external stellar transits. Compared to the power of another star, Jupiter is not even half as powerful, and we have to bear in mind that there are thousands of stars in the Milky Way that are much brighter than our own. If one of these stellar giants crosses the path of our Sun, it can cause all kinds of turmoil. Imagine the structure of the planets within the system as a bit of a constant tussle. At the moment they are all moving quietly in their orbits, but there is always a bit of jostling, pushing and shoving. Such changes are incredibly slow, but they do happen. A passing star is an event that doesn't just happen from one moment to the next. A foreign star would slowly approach and pass our Sun over thousands of years. This gentle scramble would then increase considerably due to the pressure of the star's gravity. The increasing pressure would lead to slow changes of position or to violent scenarios where entire planets are rejected from the system. The current study suggests that around a third of Neptune's current eccentricity could have been caused by earlier stellar encounters. Our neighbor Mars also shows anomalies that speak for such a scenario, and Venus has probably also undergone changes. These new findings impressively demonstrate what a complex and dynamic structure our solar system is. In our cosmically tiny system, there are constant changes that are influenced from the outside. If we want to understand our solar system, we need to understand the entire galaxy and the universe. Click subscribe now and be part of every new video.